I just discovered this while programming my game. It takes a little explanation, but it's so intuitive once you understand. Here's what's happening. Imagine a room with a wall-sized mirror. The mirror is basically just a flipped version of the room you're in. When we look at an object in the mirror, we know that our sightline looks like this. It's crooked, like politicians. But what do you actually see? You see a straight line from you to the object because your eyes see that mirror room as real. That's when I had my epiphany. Any reflection can be described as a straight line if you pretend the mirror rooms are real. Imagine you are playing pool and trying to angle a shot. Where do you aim? All you have to do is imagine a flipped pool table next to yours and aim for the imaginary ball over there. I just made that sound real easy, but you have to accurately aim at something that isn't there. So now that we've established this foundation, we can take it to the cool part. Yes, maybe you figured this out already, but you can keep going for as many reflections as you like. Imagine the room has mirrors covering all 4 walls. Unfold and unfold to get this endless plane of mirror rooms. And now you can look at any point across the rooms and refold to see the actual path. Maybe you guys don't see the usefulness of this. Well, the reason I was even thinking about this in the first place is because I'm making a game where you roll dice. I wanted the dice to bounce around the screen and finish rolling in a specific spot. Instead of having to calculate some turning, complicated path and then move the dice along that, I just calculate the straight mirror line and move the dice along that simple path. And then I have the program basically refold it so it looks like it's bouncing along the screen. And by playing around with this, I noticed some interesting features. The amount of walls you pass through with the straight line actually tells you how many bounces there are going to be. Each added layer out in the mirror rooms actually tells you how many opportunities there are to have that many bounces to get to the target. For example, with just the one room, there's only one way to get to the path with 0 bounces, straight line. There are 4 different ways to get there with 1 bounce, which makes sense because there's 4 walls. Each of them presents an opportunity to bounce to that location. 2 bounces has 8 ways, 3 bounces has 12 ways, 4 bounces has 16 ways. So I can easily decide how many bounces I want by aiming for a more distant room in the program. This was so cool. Something that seemed like a daunting task was now easy. Easy in theory. I knew how to solve my problem, but I kept programming it wrong. Then I had to figure out how to easily display it for this video to show you guys. So that took a little more work, but I figured it out. There are things like this that come up when programming where you make a discovery that brings success, but it's kind of hard to explain to other people why you're so excited. But this, you can actually see working. In some ways, I don't even need to explain anything. You can just see how cool it is. So, in the end, when you unfold a reflection, you get a straight line. And that's pretty interesting to me. Well, this only works with specific room shapes that create proper tiling pattern, but I didn't think I need to go into that. It works with rectangles, and I gotta go. Goodbye. Psst, here's the information. I programmed it in C# using Unity, but I'm sure with my comments explaining things you can convert the process to whatever you're using.